Hi everyone. So we've already done a video on lexical analysis using Flex, and I thought it would be a good idea to do a video on Bison as well, which is used for the parsing part. If you're not aware of what lexical analysis or what parsing is, go watch the videos in the Theory of Computation compiler series. And if you haven't watched the video on lexical analysis using Flex, that's in the description as well. So just check it out there. I've got a very simple lexical analysis program, so a Flex program here. And if you remember, this is the definition section, this is the rules section, and I've already written the driver program. So let's just write some very basic rules. So the very first rule that we'll write will be for a number. So let's just write 0 to 9 plus. That's the regular expression for a number. And what we want here is that it should print that it's a number. So let's just have it print number, and that's it. We'll also add a \n, which will have a return 0, which means that as soon as I hit enter, my program will end. For anything else, I want nothing here. So we can now run this program. So if we do flex lexer.l, this should create the lex.yy.c file, and I can compile it using gcc. It is giving me a warning which I'm going to ignore for now, and let's run our output file. So now it's waiting for the input. For example, if I enter, let's say 23, it's going to print number and the program is going to end. We already know all of this because we've done lexical analysis using Flex. Now what we are also going to do here is we are going to add a parser. So let's just call it parser.y. That's the extension for a parser. And the way a parser program looks, so the way a Bison program looks, is very similar to how a Flex program looks. So I've got the definition section here, and I'll also have a rules section. So this is my rules section, and they'll once again be separated by the 2% symbols. So I'll write the rules here, and then I'll have the final section where I'll actually write my driver program. So let me write that first. So here what I need to write is just like we wrote yylex here, I'm going to write yparse. And that should be it. I can do a return 0 right here. Now the rules that we are going to write in our Bison program are going to be context-free grammar rules, so parsing rules basically, instead of the lexical analysis rules that we wrote here. And what I also want to do is I want to get rid of the driver function right here. So the Bison part is only going to work with the Flex part, so these two are going to be working together, and I only need the driver once, which will be in my parser program. So here before we write the rules, one thing we need to do is we need to add a few symbols. So the way I introduce a symbol is I write token, and let me create a token called EOL, that will be end of line. And what I need to do subsequently is whenever I enter a \n, I want to return EOL. So like I said, these two are going to be working together. So once I add this EOL token in my parser, I can access it in my lexical analysis program as well. So when I encounter a \n, it's going to return an EOL. And what I also want to do is I want to write here, I want to return a number, but along with this I also want to add another line which will be as follows. So I write yyLval .num, and I'll get to what yyLval is in a second. But what we want to do here is I want to write a to I, and if you remember, a to I converts a string to an integer. So what string do I want to convert? It's the YY text, which is the text that this regular expression matches. So it's going to take a number, so like I said, 0 to 9 plus, and it's going to convert that to an integer, and then it's going to return a token called number. So now getting to what this YYLVAL is going to stand for, I'm going to create a union here. So I create a union like this, and within this I add an integer called number and a character called symbol, let's say. So this means that the union means that it could be any of these values, so it could be a number or it could be a single character symbol. So what this is going to do is it's going to put into the integer part of it the text that I got from this regular expression, and then it's going to return a symbol called number. Once again, since we've returned a symbol called number here, we also need to add the token right here, so let's do that. So I'll add a token called number, but what we also want to do is we want to specify a type for this token, and the way we do it is we write it within angular brackets, and the way to say that this is a number is to just write num. And now at this point we could give this a number and it's going to go to the parser, but for our parser we haven't really written any rules. So the first rule that I'm going to write is that my input could consist of an expression followed by an end of line, or it could just be an end of line. So I hope this makes sense to you. So my input could just be an end of line, in which case there's nothing in that line. And now since I've written the word exp here, I also need to, so everything right here needs to either be a token that I've specified right here in the definition section, or I need to have a regular expression for that as well, sorry, a rule for that as well. So I am going to write a rule, and specifically in the case of expression I'm also going to add a token. And the reason I do that is because I want to say that my token is my expression is a number, so I'm just specifying a type for expression, but I'm also going to add a rule for this. So an expression could be a number, so that's rule number 1, or it could also be a number plus a number. So I'm going to write number plus number right here. And at this point what I also want to do is let me separate this out into different lines. So what I also want to do is I want to specify the output. So what's the output if the expression is a number? And the way I specify the output is I use two $signs. So this is the output, this is equal to the first input, so I just say $1. And in this case, for example, it would be the output will be equal to the first token that I have here, followed by the third token that I have, so that is my output right here. And let's just end it at this. What I could also do at this point is a smart move, which would be to write exp here instead of the word number. And the reason I'm doing that is because then I can also have an expression plus an expression instead of just restricting it to number plus number. And of course a single number is a valid expression, so even if I give number plus number, that does fall under this rule right here. So this is what I do, and what I'm also going to do is I'm going to specify what I want to print here as well. So let me separate this out into different lines. And now what I want to do is I just want to do a printf, and it'll be a %d followed by the first argument, so $1, and this should work ideally. And at this point we could try and run our program, so let's just see what happens. So the first thing I want to do is I want to once again do the flex part. So it has overwritten this lex.yy.c file, and I also want to now do a Bison, and the options that I want to use here are -d and a -t. So let's not worry too much about what those options mean right now, but I just give it the parser and I hit enter. It is giving me a couple of errors, and what those mean is that because this is a token right here, I shouldn't have any rules. So the way I specify that this is not exactly a token is I say type instead of token. So I'm simply specifying that the type of an expression is num, and then I can try this once again, and this should once again work, but it's giving me an error because I've got plus here and I haven't specified that as a token. So let me do that as well. So I write token plus, and that should be it. So once again, let's try it now. It is giving me a conflict, but I'm going to ignore it for now. What we can see here is that it has created a parser.tab.c file and a parser.tab.h file. So it has created a header file as well. What this header file contains is a lot of stuff, but what's also going to contain are these tokens right here. So all of the tokens that I've specified will be somewhere in this. And what I want to do now is I want to go to the Lexer and I want to include that parser file. So I do a parser.tab.h here, and this is how the lexical analysis, the flex program, is going to know about these tokens right here. So let's go ahead and do the flex part once again, and at this point I can now do the GCC part as well. And this time when I do GCC, I not only want to add lex.yy.c, but I also want to add the parser.tab.c, and let's hit enter. It's giving me a few warnings which I am going to ignore, but let's see if it's giving us any errors as such. So one of the things that's specifying is that I need a yy error function. So let's just add that function as well here. Now what the yy error function does is whenever none of these rules match the rules that we have given here, if none of these match, then the control is going to jump to this yy error function, and there will be some kind of an error string. So what we'll do here is we'll just do a printf, and we'll say error followed by a %s, and we'll just print the string, and let's add a return 0 as well. So once again, let's try it now. So here we've once again got a few warnings which I am going to choose to ignore, but it has now created my a.exe file. So let's just try it out, and let's just give it a number which is 9, and you can see that it's printing 9. I'm going to stop right here and try and go through an explanation of what is happening. So let's just look at what is happening right from the lexical analysis stage. So this is detecting a number right here. So the Lexer detects any number, so 0 to 9. When I enter 9, what the Lexer does is it identifies this as a number. So that's the first step. And if you remember the lexical analysis stage, it involves recognizing what each of the words in a program refers to. So for example, a lexical analyzer would do things like it would detect a space and it would say that this is a white space, and it would also detect a tab and it would also say that this is a white space. It would recognize this as a number. It would also recognize, let's say we have the word if, it would recognize this as a keyword. All of this is the job of the lexical analyzer. So in our case, what is happening is it recognizes that 9 is a number. And it passes that accordingly to the parser. So it says that this is a number, and along with the number, it also passes what number it is. So it also passes that this is the number 9. But primarily it identifies 9 as belonging to the number token and passes that to the parser. What the parser does next is and the lexical analyzer also detects after the number 9, it detects a new line. So it also returns an EOL. So when I hit 9 followed by a new line, what gets passed to the parser is number EOL. This is what gets passed, and along with the number it also passes what number it is. So it passes 9. So this is what the parser gets as an input, and what the parser now does is it starts from the first rule that we have given, which is for input, and it says that an input can be an expression followed by an EOL. Now I still need to evaluate what expression is, so let's hold on to this and let's jump into the rule for expression. So it goes to exp and it detects that exp is a number. So it stops right there because we don't have anything else, we don't have a plus or anything. So what this rule does is it specifies that the output of this entire exp thing should be the first input, which is the number itself. So now this gets changed to, so exp EOL gets changed to now number with 9 and EOL. And next what we are doing is we are printing whatever the number is. So it's this part right here. So we are printing the expression, and if you remember, the expression got evaluated to the number 9. So it's just going to print 9, and that's the output that I get. So I hope this makes the flow clear. And next what I want to do is I want to add some regular expression for plus as well. So the way I would do that is I would just add another rule here. I add the regular expression, just the plus symbol, and I just say return plus. That's all I have to do. And at this point I also want to take care of white spaces, but what I realize is that I've got a dot rule right here, which means that white spaces, which means that the rule which is space and a tab and do nothing for that is anyways included in this part, so I need not explicitly mention that. But if you want to do something else for a white space, you can do it this way. So let me get rid of this, and once again I save this and I can do all of my steps again, which is the flex part, the Bison part, and then follow it up with the GCC part. So once again I've got warnings which I'm going to choose to ignore. So now if I run the program, when I hit 9 it should give me a 9, so that is expected. But when I do a 3 plus 2, it should also give me a 5. It's giving me a syntax error, however, and the reason that's happening is because my program can basically just accept one line, so it can't go beyond a line. And The way I would solve it is I would say that my input, let's just change this to line. So this is one line of my input, and my input itself can be, first of all, it could be nothing. So let me just hit an enter right there, and then I add a recursive definition for my input where I say that my input could be a line followed by an input again. So let's try this once again, and hopefully this should work. I don't really need to do the lexical analysis part now because I didn't change anything there. So let's just go ahead and do the GCC part. And now we run our program. So let's say I enter a number first, it prints that number, and now I do 1 plus 2. You can see that it's giving me a 3 right there, and I can keep doing this for as long as I want. I could also add spaces. I could say 5 plus 1, 2, 3, that's going to give me a 128. So this is working pretty well, and I can hit a Control D or a Control C to stop my program. Further, what you can do is you could say that I can have, let's say, a minus symbol here, and I do a return minus, and I could also have a multiplication symbol here, and I can say that this is a return multiply. And then within my parser I need to add all of these tokens, so I do a plus space minus space multiply all of these tokens, and within my expression now I say that my expression could be a number, it could be an expression plus an expression, it could be an expression minus an expression. So in this case the output would be the first one minus the third one, and it could also be an expression multiply expression. I'm probably not using the best word there, but in this case it would be times $3, and that's it. This should once again work. This time I need to do the flex part as well because I made changes there. So I do the flex part, the Bison part, and now the compilation part. So let's try running it, and now let's see if it can give me the result for 3 into 2, and as you can see it is giving me the result. It should also be able to give me some result like this, and you can see it's giving me that as well. Let's just try if this can do a plus 5 and a plus 10, and as you can see it did even this part correctly, and the reason it did that was because we have specified that an expression is an expression plus an expression. So what it's really doing is it's first evaluating a number plus a number. So let's just say it's evaluating 123 plus 5, it's getting 128, and then it's saying that again 128 plus 10 is once again falls under a number plus number. So this whole thing is an expression, and this thing is an expression as well. So it's able to do that. Now let's also try whether it can do 5 plus 5 into 2, and this time what I want to see is whether it gives me the result as 15 or 20, and you can see that it gave me 15, which is actually correct. So that's pretty good. If it's not giving you the expected result, what you could try doing is try messing around with the order here. Let me try and do that right now. So I add this expression, this rule right here, and now I can stop my program and I can do the Bison part again, compile again, and then try running it, and let's just see what it does now. 5 plus 5 into 2, and you can see that it's still giving me the correct result. And let's just see what it does with 5 times 5 plus 2. In this case you can see that it's giving me the incorrect result, and The reason that's happening is because it's saying that this is an expression and this is an expression, and based on that it's first evaluating the second part. So it's basically just doing a right to left thing irrespective of the order in which I write my rules. So even if I add this here, it is going to give me the same result, which is the wrong one. So I was doing 5 into 5 plus 2, and you can see that it's still not giving me the expected result. What I could do is I could add rules for parentheses as well, but I'm not going to do that. This video has already gone for too long. I'm hoping that you're able to do that yourself, but I hope that this video gave you a brief idea about how a Bison program is written, what exactly are these rules that we are writing right here, and with this you should be able to make some kind of a basic calculator thing which does all of the add, subtract, multiply, divide operations. And that's it for this video. I hope you learned something from this. If you did, don't forget to give it a thumbs up, and if you haven't subscribed to my channel yet, please do subscribe. I'll see you in the next video. Until then, bye bye.